So let us see a very basic demo of how to create an agent. So all of you can see the screen, and we are using the LangChain library for doing this task. Initial part is all the same, API keys, Azure API keys, all that we already did. Here is a bit of text I've given you to explain the framework again. And see this part. This is exactly what I was explaining. See, I just tried to explain you two different types of tools. One is a Python tool, and one is basically a DuckDuckGo search tool. Okay, so these are the Python, the tools that we are able to see. This is very interesting. Actually, a couple of days back, when we started the session a few days, 2 days back, remember I told you OpenAI has signed an agreement with Windsurf. Windsurf is actually a coding platform, right? So just like Cursor, Windsurf is also like a coding engine, right? And a lot of companies are actually trying to come up with these kind of integrations. If you think about it, if you think about another very, very practical example of agents, let me show you. You can actually run code inside ChatGPT, So if you go to ChatGPT, you can actually run code inside it. So I can literally say, you know, I can literally say build a classification model. I'm just taking a basic machine learning task, okay? So build a classification model. I'm taking a simple classification task right now. Yeah, this might be a little technical, or maybe I can take a more generic task which everybody can understand. So write a program to write a program to add two numbers. I don't think there's any rocket science about this. Very very basic thing, right? So write a function to add two numbers. Generate the code and allow me to test it. Test a function by calling it. I know I'm making it too advanced right now, but you can see that you can literally do this with very little supervision also. But anyways, I can run this, and what it will do is, what the GPT model will do is, it can go and literally generate the code for me. Not only that, it even has the ability. It even has the ability to call this. Right, it even has the ability to run this at the backend. Now, not all the time. It's again limited by, there are some restrictions. If you have a very complex thing, it may not run, but it does have the ability to even use a Python runtime behind the scenes. So that's one of the ways to basically work it out, how this is working behind the scenes. Okay, so if I say run the program, if I just say run the program, okay, so whatever program I wrote, see, look at this. Did you see how it ran it? This is where the overall the Python runtime is actually getting used. Okay, so this is the Python runtime that is used behind the scenes. So remember, the language model is GPT-4 Omni, but ChatGPT.com is an agent. So it is a language model, but it is also connected to a Python runtime. So I can write any query, and it will send it back into a Python runtime engine, and that is what is executing the code. But this capability, everybody will not have. Like, if I, for example, at least last I checked, Gemini did not have the capability. I'm not sure if they have recently modified it or whatever. We need to check that. But if you take a look at it, Gemini inherently doesn't have the capability to run the code. Okay, so it will generate the code nicely for you. See, here I'm able to very nicely generate the code. Very detailed, right? Gemini is very detailed in terms of how if I ask a question, Gemini is it's a very large context window, I told you. So that's why usually the outputs in Gemini will be a lot bigger. See, it does a lot more. Simple question I'm asking, but it tells me so much. The output tokens are huge, right? And you can see, now I can go and if I say run the code, run the program. If I say run the program, uh, look at this. Can you see? Can you see? I cannot directly run a program in the same way you could on your computer. So these are some of the limitations you need to be aware of, right? So again, I mean, Gemini is great, huge context window, but in terms of coding tasks, it will write code better. It will write code in a very good way, but it will not inherently run the code for you because it is not connected to the backend to a Python runtime. Okay, so these are again things to be aware of. These are all agents what you're seeing on the screen. So whenever you access Gemini.google.com, it's an agent. So it's not connected to a backend Python runtime the same way that maybe a chat GPT is connected to. It actually ran it successfully. You can actually copy paste any code and say run this code, and it'll actually run it for you. Although not very advanced stuff, because remember, if something, I mean, don't try to copy paste your vector DB creation code, and it will not do that because it needs GPUs and it cannot use GPUs obviously. Okay, so very basic code snippets it will run, but not some advanced snippets and all it will not run. I hope over the course of this discussion, everybody appreciates what agents are in a better way. So this is where I have actually created the tools first. I told you how we use LangChains and the tool classes to create the tools. Okay, so you can see this one in action. So this is the Python REPL. So we instantiate Python REPL, and all of this is defined here. See, from LangChain. So from LangChain, we get Python REPL. From LangChain, we also get DuckDuckGo search and Yahoo Finance. We will use both of these in our demo here, right? So we instantiate the Python REPL, and here we basically wrap this REPL as a tool. And this is the way how we wrap it as a tool. We use a tool class in LangChain. Again, this is a very simple way how we are creating a tool. But if you want to do it a little bit more manually, we will see later on that we can actually create a function. You can create a Python function to do this. But here we simply use a tool class to wrap it as a tool. And if I want to call the tool, I can simply say REPL tool.invoke. This is all code, okay? This is all syntax. I mean, as long as the concept is clear, what we are talking about from now for the next half an hour will be just syntax. That's it. So don't worry too much about the syntax. Understand the end-to-end application flow, because you already have extremely powerful code editors which will do all this heavy lifting work for you. So please don't get too nervous and confused with the syntax. Okay. Okay. So now this is the same way how I'm instantiating the DuckDuckGo search tool. So I'm instantiating DuckDuckGo search. I'm wrapping it as a tool. The tool name equal to DuckDuckGo search. This is the same name I'm giving. Okay. Whatever name I gave here, same name I'm giving here. Description part is very important because I told you this is the only way that, because this tool is a worker. Okay. How will your manager know what you can do? You will have a manager, right? Your manager will only know what you do based on your resume, based on your interview, based on your skills, whatever. You have to, you have to tell that, hey, my name is Sayan, I'm very good in doing this. So that is what how the manager will know. Okay, there's somebody called Sayan in my team, and Sayan is very good in Gen AI, right? So next time I get any user query on Gen AI, I'll give it to Sayan. So for that to happen, the description has to be proper. The description is actually a very, very important thing. You must describe the functions correctly, the tools correctly, sorry. Okay. So by now we have defined two tools. And if I want to test out my search tool, you can see search tool.invoke is the code I use. Very simple. Who is the founder of TestHub? Straightforward. Now, moving on, let us see the complete end-to-end implementation with respect to an agent. What we have done until now, we have defined two tools, right? Let me show you. We have defined two tools. So we have defined the DuckDuckGo search tool. We already talked about it. And we have defined the Yahoo Finance tool. Okay, see the code. So step one, we have defined the DuckDuckGo search tool by wrapping it in the tool class. And step two, we have defined a Yahoo Finance tool by wrapping it in the tool class. Okay, so this is the two tools that I've instantiated. And this is the part where I'm defining the React prompt. Because remember, the entire functioning of the agent is ultimately controlled by a prompt. There is a prompt that is working behind the scenes, right? The entire functioning of the agent is ultimately controlled by a prompt. There is a prompt that is working behind the scenes. And this is where I'm actually using a kind of a React prompt. I'm not defining the React prompt manually. What I'm doing is I'm simply taking it from some open source place. Okay, so this is where I'm pulling it from. Okay, we'll see some demos where we'll even write the prompt manually. I was just trying to quickly look up the prompt where it is. Okay, just a minute. Yeah, this is where it is. Yeah, I've simply just clicked on the link. I just copy pasted the link here. And this is what the React prompt looks like. All of you can see. So I've simply pulled it from here. Can you see? I did hub.pull hwj17 React. So this is the Langsmith hub. And in case you're wondering where is hub defined, so this is where I instantiated all those libraries. Okay, so all this is LangChain import hub. When I say LangChain import hub, I can actually pull all the resources from here. This is how I'm actually pulling this particular resource. Okay, so if you want to use it, you can also use it. So if you just click on try it, if you just click on try it, you can actually try the prompt here. And if you want to use it, it will give you the same query, how you can go back and use it. So this is basically what we did. Can you see? So from Langsmith import client, this is just an alias that I'm defining. Okay, and I'm just saying client.pull, straightforward. Okay, so this is how we can use it in the the Python SDK. Anyway, so this is what the prompt looks like. All of you can see. It looks very simple. Simple, plain and simple English is what we have defined here, right? So answer the questions as best as you can. You have access to the following tools. So this is the prompt for the LLM. So the LLM will it has access to these tools. So this is the prompt for the manager. So we are telling the manager in advance that okay, you have access to all these workers. These workers have been very clearly defined, which we have already done that later, and then use the following format. Okay, so question, thought, action, observation, and repeat thought, action, observation n times until you know the final answer. Okay, so this is the way how we do it, and it can be more detailed. I mean, this is a very simple example of a prompt, but it can be more detailed, right? So we do that, and this is how we finally instantiate the agent. Remember, I told you, agent is basically LLM plus tools plus prompt. So these are the three main components of an agent. Okay, so there's a language model. There's a language model that we've been talking right from day one, the GPT-4 Omni model or whatever model you want to use. There is a prompt that we just now talked about. There is a React prompt that we have to write where we explicitly specify what framework we want to use. Now here is React, but if you want a different framework, let's say Reflection, you will have to write and adjust the prompt accordingly. Okay, and we also specify the list of tools. What are the tools that we have? Okay, and we specify the tools as a list here: search tool and finance tool. Okay, so straightforward. And now we are just running the prompt right now. So sorry, testing the agent right now. What is the latest stock price of AAPL? Okay, so we can just test out the prompt. What is the latest stock price of AAPL? How do we solve that problem? So given a question, what is the latest stock price of AAPL? What we can do, we can go and effectively, first the agent will figure out what tool to use to solve the problem. Okay, so first the agent will decide what tool to use to solve the problem. So it has a list of tools available. One is DuckDuckGo search and one is this thing. So it will first figure out what tool to use to solve the problem. So turns out that it has to first figure out what is AAPL. So first it has to go to Yahoo Finance and it will try to find out what is the corresponding ticker symbol of AAPL. That is the first step. Okay, so what is the corresponding ticker symbol with respect to AAPL? So first find that out. And once we do that, once we find out what is the corresponding ticker symbol for AAPL, which is Apple, then you go to DuckDuckGo search and you get the latest stock price of Apple, which is 189.87. Okay, so that's the way how we do it. All right, so we can see that given this question, this is the original question the user asked, the agent will respond the latest stock price is 189.87. Okay, so but the magic is all happening in the intermediate layers. There can be multiple calls that are happening. There can be multiple external agents or extensions that we have connected this to. Yahoo Finance API, DuckDuckGo Search API, even Google Search, by the way. Google Search is paid. That's why we haven't used it. DuckDuckGo is free. But if you can also use Google Search, but you need to have an API key and all that. Okay, so you can see this one. And if you scroll down, you're just asking one more question. What was TSLA's quarterly revenue from the latest earnings call? And same way, we are first trying to figure out what is the corresponding uh, name of the company with respect to its ticker symbol. So TSLA stands for Tesla. So that's the part that we are able to figure out from Yahoo Finance News. And once we get that, now we go to DuckDuckGo search and we are able to figure out this thing. Turns out it says the revenue data is not available. Okay, so that's what is found out. All right, so this is how we do this. And the next example that I showed is how to create a data frame agent. Data frame agent is also like, this is the same use case that we were talking about. And you can see, I took a data frame, a sample data frame in Pandas. So we took a sample data frame called bank data. So this is the bank data set. So it consists of customer information with respect to a customer's job, their marital status, education, default status, balance, and all that. And we are trying to do some querying based on that. Okay, so this is the built-in function. We are not having to do this manually. This is a built-in function that LangChain already comes integrated with. LangChain gives you this particular way to, it has a built-in agent that you can directly use on data frames, Pandas data frames in Python. Okay, so you can specify the language model, which is GPT-3.5. You can specify your data frame, which is bank data. This is my data frame in Python, and that's it. It'll straight away work. How will it work? Well, you can give some sample inputs. These are some sample input queries that I'm giving. How many customers have defaulted on loans? What is the average balance maintained by a customer? How many customers have subscribed to a term deposit? You can specify some sample inputs here. And once you do that, let me show you the execution. So this is the execution. You can see how many customers will default the next month, and see how it is working. So given this question, how many customers will default the next month? I'm sure many of you in this audience who know how to query data frames or Python, you know how to get this right. If I ask the question, how many customers will default the next month? What do you do? What do you do? This is the query, no? Df default. So default is my column. So you want to access the column and then do value counts, right? So when you say df default value counts, what you get is basically this. Okay, so from the data frame, you can say value counts, and that will give you all the unique categories, no and yes, and how many of them are there. And from here, the agent is able to figure out that, okay, there are 168 customers who have defaulted, or maybe let's say who will default. Okay, so you can see to determine the number of customers who will default next month, we need to analyze the default column of the data frame. So this is the intelligence of my language model. So that's the way how we are actually going about it. Okay, and this is also very interesting. See, however, based on the provided data, it seems that a default column indicates the current default status of the customers and not a prediction for the next month. It even has the intelligence to figure that out. Okay, so see, it is so detailed actually. Okay, so the agent is just working on the data frame. So based on your question in natural language, we are able to generate the result in English. Okay, so we don't have to write the code in a way. So next time you have any problem, you have any table in a data frame, any data available in a data frame in Python, you can literally ask something in natural language, and the entire exploratory analysis will happen automatically behind the scenes. Okay, so I have a slightly more exhaustive notebook where I've kind of walked you through this a bit more in detail. So let me just bring up that notebook for you. So in this notebook, I've actually covered this particular part in a bit more in detail. Okay, so I wanted to take you through this notebook. And in this notebook, I've actually covered both the approaches. One, how you can query from a data frame, and two, how you can query from a SQL Server database. So both of those things I've actually done in this particular approach. So this is the other example I wanted to show you. Very similar, very similar. And in this entire thing, we are using LangChain. You can see LangChain is giving me access to all these things. We were talking about this create data frame agent. See, it is already a built-in function in LangChain. We don't have to do anything manually. We don't have to do anything manually. So LangChain already gives me the capability to work with it. Okay, so this is the thing. And similarly, we also have this SQL database toolkit. So this is how we will create a SQL agent. So we'll create a data frame agent and also a SQL agent in this exercise. The first step, define the language model. This is the Azure language model that you can instantiate and define. Next, what we are doing, we are reading the data frame. The data frame name is saheart.data. And we are creating the Pandas data frame agent, the same thing that we discussed a while back. And you can ask it some question. Let's say, what are the different columns in my data set? If you ask it this question, what will happen? Okay, so we are asking the question, what are the different columns in the data set? So given the question, the model will be able to automatically frame the corresponding code for it. So given a question, the agent will be able to automatically figure out, the language model will be able to automatically figure out, okay, what is the code I should write? So df.columns. Okay, so if you know that df is my data frame, so if you have to do it manually, this is the syntax you will use to figure out what are the columns. So the columns will be listed out as a list, and the final result will be something like this. But as an end user, you will not see all this, right? You will not see any of this. As an end user, what will you see? Okay, as an end user, what will you see? Let me hide the output. Okay, as an end user, you will only see this thing. Okay, you will only see this this part. So none of this part you will see. You will only see the last part. Okay, so similarly, how many missing values are there in the data set? You will get only the answer like this. There are no missing value. But behind the scenes, what is happening? This is the Python syntax that is written. So df.isna is a way to check for missing values. Sum. Okay, and you can see this is very interesting. Can you display a brief summary of the columns? Okay, and if you can make it more advanced, you can make it more advanced. Like for example, this one, show me that and distribution of age of people with this. Label the axis. Finally, comment on the principal trend observed. Look at this. It's a bit more in detail. So first, it will write the code to generate the plot. It will actually create the plot because there's a Python runtime that is also used behind the scenes, right? So when you ask this question in natural language, what will happen? This is like what I was doing in ChatGPT, right? You can ask a question, and GPT will generate the code. It will run that code, create the graph, and it will give you inferences about the graph. And all this is possible with agents. So you can see how we can build end-to-end systems with agency. You can create the histogram, and it will also comment that it's like a left skewed distribution and all that. See, it actually explains what this graph is doing. Okay, so this is the heat map. Some of you might know what is a heat map in data science. Okay, so this is again technical topics, but the focus here is just to show you how to create it. So you can see when I say draw heat map to show correlation between all the columns, so it will generate the heat map. That's it. And the code behind the scenes is this df.core, sns.heatmap, cbound library is used to create the heat map, and then plt.show. Okay, so all this is written behind the scenes, and then it gives a small summary what the heat map does. See, this is a very detailed summary, no? Very interesting. So it actually summarizes the heat map. Not only does it create the code, but it also creates the heat map, and it also summarizes the heat map. What are the key observations we are getting from the heat map? So this is the power of agents. They are not just language models. They are not just text completion engines. But the language model, if you ask it a question, it will just generate the code. Here we are not just generating the code. Here we are doing everything. I want to solve the problem. You do whatever it takes to solve the problem. I want to know this. I want to get the heat map and get some inferences. Summarize the trend. I want to solve the problem. So don't just write the code. If you do this in Gemini, what it will do? It will go and give you the code. But if you do this in a true agent, it will not only give the code, it will run the code and it will actually solve the problem. It will give you the output the way you expect it. Behind the scenes, it is calling multiple things. That's what it's doing. So this initial part was about how to query Pandas data frame in Python. The next part of the demo is something which I believe will be much more relevant for everybody, is how to query databases. If you have a database, if you have a SQL Server database or an Oracle database, how can you have an agent directly query a database in natural language, using natural language? And there is a very simple open source way you can do it. So LangChain already gives me access to a SQL database. You can see. So we can connect to a, so in this case, what I'm doing is I'm connecting to a sample DB file. So I've given you a sample DB file and we are connecting to a sample DB file. You can take any database, by the way. You can take any database. Okay, so we are just connecting to a sample database. Just some quick checks we are doing. Sorry, actually what I'm doing here is, no, I'm actually creating a database. Yeah. Yeah, so I'm actually creating a dummy database. Okay, so creating a dummy SQL database, establish the connection, give it a database name, and create the table. This is the create table we are doing. It's an employee table I'm creating, and then we are inserting some values to it. So there are 4 rows in the table, right? So you can see that we have an employee table. There are 4 rows in the table. Very simple. And now what I can do, I am instantiating the agent, create SQL agent. That's it. This is again part of LangChain. So data frame, we had create data frame agent. Here we have create SQL agent. So what you do, you specify the name of the language model. You specify the toolkit. Toolkit will have the data BDB name and the LLM, and that's it. Straightforward. And you can ask a question, name the columns present in the database, and the answer will be this. Behind the scenes, what is happening? Behind the scenes, it is writing the, so behind the scenes, it is actually doing all this. This is the thought action observation chain you can see. It is listing out the tables, employee, right? And then employee table, it is figuring out how to get the columns and all that. See how it's actually able to retrieve all this. Okay, so what is the maximum salary paid to an employee? To whom it was paid? This is a slightly complex query, right? So, and very interesting. This is actually quite hard because in my database we only have a single table. You might have multiple tables in a database. Database can consist of several hundreds of tables, right? And it can have a very complex schema also. So if the language model is powerful enough, it will have the ability to even understand what table to query. But you need to give it a good amount of schema information. If the language model has access to the schema information, okay, and that will all be part of the system message. When you write the prompt, you have to write it in the system message. What is the schema and all that, right? This is the default one we are doing right now. But if you specify the system message correctly, and if you specify the schema information of your DB, then even if you write complex queries involving joins, inner joins, outer joins, involving 7, 8 different tables, it will still be able to do it for you. And that is what makes it so powerful. So the magic is again in the prompt. A detailed prompt, a detailed system message, you can do a lot of magic actually. Okay, so you can see what is the maximum salary paid. The answer will come out here, and this is the query that was written. Can you see how it methodically went about it?